Okay, so we're gonna dive into this lesson. The goal is to determine whether or not a rational number is a square number, or in other words, a perfect square. So let's remember a rational number are fractions with integers in the numerator and denominator, and the denominator has to be non-zero. Or if it's in decimal form, the decimals need to be terminating. So here are some strategies for figuring out whether or not a rational number is a perfect square. So for fractions, all you need to do is look at the numerator and the denominator, and if both are perfect squares, then the rational number is a perfect square, or it's a square number. However, if they are not perfect squares from the beginning, then you might want to reduce them to lowest terms, and maybe it may be a perfect square. And if it's already reduced to lowest terms and you still don't find a perfect square in the numerator and denominator, then you can say that the number is not square. And for decimals, you can put it into your calculator, and if the answer terminates, or if the decimals stop at some point, then the number is a square number. And if it appears to not terminate, then you can guess that it is not a square number. So we're going to go through a couple examples here. So let's look at A. 8 over 18. If you know your perfect squares, you can figure out right away that 8 is not a perfect square. 18 is not a perfect square as well. But you might want to try reducing it to see if it could become a perfect square. So I realize that they're both even, so I want to divide them by 2. And this becomes 4 over 9. And I look at that and I say, oh, 4 is a perfect square, 9 is a perfect square. So then this probably is a square number. And to make sure, I'm going to take the square root of both. It's going to get me 2 over 3. And to just confirm my answer, for something to be a perfect square means you can multiply two numbers together to get your original answer. So that means that I can multiply 2 over 3 and 2 over 3, and I should be able to get 4 over 9, or in this case, also equal to 8 over 18, if I multiply these by 2. So I can say, 8 over 18 is a perfect square. All right, so let's go to B. 16 is a perfect square. 5 is not a perfect square. So because I can't reduce this fraction anymore, it's in its simplest terms, I can say 16 over 5 is not a square number. Since 5 is not a perfect square. And now 2 over 9, I see right away that 2 is not a perfect square. However, 9 is a perfect square. And 2 over 9, I can't simplify this anymore. So I could say 2 over 9 is not a perfect square. Since 2 is not a perfect square. Perfect. So every time you give your answer, you have to make sure that you prove why a rational number is or is not a perfect square. All right, let's move on to decimals. So for decimals, I would just put into your calculator. I would take 6.25, take the square root of it. And I calculated this already. You should get 2.5. And since the decimals terminate or stop, since the square root of 6.25 is equal to 2.5, and the decimals terminate. Oops, I didn't spell it right. Then 6.25 is a square number. And if I go to this next one, I take the square root of this. I'm going to get a really long number. So square root of 0.627. So that's what I get. And in this case, the decimals still terminate. 0.7918333. Oops. 1579. However, there's a problem with this when you're trying to enter it into your calculator. So the problem is some calculators don't go on, or the decimal places don't go on for very long. So the problem with using a calculator is calculators, they have limited decimal places. So it is difficult to determine if a rational number is a perfect square. So just